Hello my dear students. So far we have learned that carbon exhibits property of catenation and tetravalency. These properties will help us understand about organic compounds like hydrocarbons, which are made up of carbon and hydrogen. Hydrocarbons are of two types broadly, and you can see on the screen. First type is saturated hydrocarbons. These hydrocarbons contain only single bond between carbon atoms. As you can see in the given structure, this is a type of saturated hydrocarbon where these black balls represent carbon and these white balls represent hydrogen. So as you can see in this structure, in between two carbons there is a single bond. So these type of hydrocarbons are called saturated hydrocarbons. The example of saturated hydrocarbons are alkanes. The another type of hydrocarbon is unsaturated hydrocarbon. In unsaturated hydrocarbon, you have this type of a structure where in between two carbon atoms you have a double bond. As you can see here, two carbons are attached with a double bond, and then in order to satisfy tetravalency, this carbon is bonded with another two hydrogens, and in this carbon also two hydrogens are bonded. These type of hydrocarbons in which double bond is present in between carbon atom are known as alkenes. There is one more type of unsaturated hydrocarbon which is known as alkynes. As you can see, in between two carbon atoms there is presence of three bonds, that is triple bond. These type of hydrocarbons are also called unsaturated hydrocarbons and their name is alkynes. There is one more thing you have to focus on. In the first structure, I talked about two carbons. So the root word is eth, and the one which has single bond, it ends with ane. So the name of this structure becomes ethane. Same way, if you talk about second type of hydrocarbon, that is unsaturated hydrocarbon, alkenes, double bond is present. So when we name it, there are two carbons, so root word becomes eth, and because of the double bond it ends with ene. So its name is ethene. In the third type of hydrocarbon, that is unsaturated hydrocarbon only, but triple bond presence in between two carbon, it is alkynes. But because two carbons are there, the root word becomes eth, and triple bond it ends with ines. So its name becomes ethyne. Now my young scientists, let us have fun in creating series of these saturated and unsaturated hydrocarbons with clay and toothpick and try to fill given table on the screen one by one. First we will talk about alkanes in detail. When I talk about alkanes, as you can see in this clay and toothpick structure, this purple colored ball represents carbon. As you know, carbon is represented with black balls, but here just to have fun we are creating some different colors. So in the center it is carbon, and these four bonds represents hydrogen. When you look at general formula of alkanes, it is CnH2n plus 2. Please have a look on screen for this. Here n is small n, which represent number of carbon atoms. So in the first member, n is equal to 1. So it is first carbon, and tetravalency is there with 4 hydrogens. So the molecular formula, when you put n is equal to 1 in the formula, it becomes CH4. This is the structure, and when you will count number of bonds here, it is 1, 2, 3 and 4. So there are 4 covalent bonds, and if you will name it, when one carbon is there, its name starts with root word meth, and since single bond is there, it is ane, which is the ending word. So when you combine both the words, it becomes methane. When you will form the second member, it is somewhat of this sort, where you can see two carbons are there, and in between there is one bond which shows catenation, and 3 hydrogens are being put in each of the carbon. So this is a representation of second member of your alkane series, which has molecular formula C2H6. So its name will be eth because there is presence of 2 carbons and it ends with ane. So the name becomes ethane. Very good. So when we talk about the number of bonds, you can count 1, 2, 3, 4, 5, 6 and 7. So number of bonds are 7 in structure of ethane. The same way you will propose the structure of propane. You can take help from the table given on the screen. My dear students, we have already done electron dot structures of carbon dioxide and oxygen molecule. We will take help of that idea and will try to draw electron dot structure of ethane. Please have a look on the screen. Here you can see one carbon has 4 electrons in the outermost shell and another carbon also have 4 electrons in the outermost shell, and hydrogen have 1 electron in the outermost shell. So all hydrogens will share its 1 electron with 1 electron of carbon, and remaining 1 electron of each carbon will form a bond with themselves in order to satisfy its valency. My dear students, the task for you is to draw electron dot structure for propane and have fun. There is one more thing you must have noticed. If you look at the series as per the table, that these are group of carbon compounds having similar structures, similar chemical properties, and whose successive members differ by a CH2 group. You have to carefully see one thing. As you have seen the first member of alkane, that is methane, with 4 single bonds, and if you try to compare this structure with this, there is presence of 1 CH2 bond extra. So when each successive member differs by a CH2 group and you form a series out of it, that series is known as homologous series. Now it's a time where you need to scratch your mind. Think, what will be the first member of alkene series and what will be the first member of alkyne series? Okay, tell me, will it have 1 carbon or 2 carbon? Students, homologous series of alkene and alkyne starts with n is equal to 2. That means minimum of carbons required is 2 to start the series. Let us find out the reason why is it so. When we'll draw the structure of alkane's first member, let's suppose these are 2 carbons catenated with 1 single bond. Since we are talking about alkenes, there will be 2 single bonds and it will make a double bond like this. Now, in order to satisfy valency, how many hydrogens should I put here with this carbon? Since 2 valencies are satisfied, I'll put 2 more. Same way, in this carbon, I have to put 2 hydrogens. We'll place red balls for hydrogen. Now as you can see, minimum carbons are 2. If suppose I start my series with n is equal to 1, then this would have been a structure which appears to be so wrong. Here, if I put hydrogen, then hydrogen valency becomes 2. So it is wrong. Minimum carbons which starts the series is n is equal to 2. So first member of alkene is ethene. Eth is for 2 carbons and ene is for minimum 1 double bond present between the 2 carbons. So the name becomes ethene. So when you count number of hydrogens for this and number of total bonds, how many it comes? 1, 2, 3, 4, 5 and 6. So in ethene you have 6 total number of covalent bonds. And please have a look on the screen to complete the entire table for alkenes. You will also draw the electron dot structures as discussed before with alkanes. Now we will come to alkynes. Same way, if I want first member of alkynes, see, in between two carbons there is 3 bonds. Had it been only 1 carbon, I cannot put hydrogen here because now hydrogen valency becomes 3, which is wrong. So, minimum of 2 carbons should be there in between 3 double bonds, and then you will satisfy its tetravalency by placing hydrogens. So, in the first carbon only 1 hydrogen will come, and in the second carbon 1 hydrogen will come. So, now count total number of bonds with me. Very good. 1, 2, 3, 4 and 5. So, total number of covalent bonds in the first member of alkyne series is 5, and the name, because 2 carbons are there, root word becomes eth, and triple bond then it ends with yne, Y-N-E. So, the name becomes ethyne. In the same way, you will draw electron dot structures for unsaturated compounds containing triple bonds. That is a task for you, my dear students. In addition to straight chains, you have cyclic structures as well. So, in order to have information about cyclic structures, my dear students, please have a look on screen. When you talk about cyclic structures and when you talk about single bond, let me show you one example. In cyclic structures, the general formula is CnH2n, which is same as that of alkenes. If suppose I want to make the structure of cycloalkanes, the simplest cycloalkane is with 3 members. I will attach 2 carbons with a single bond. Then I want to make a cyclic structure out of it. So, see, I tried to make a circle in a triangular shape. So, this is a cyclic structure for alkanes with 3 carbons. In the same way, you can form the structure with 4 carbons, 5 carbons, 6 carbons and have fun. The second type which we need to understand, we have to discuss benzene. In benzene, there are total of 6 carbons with presence of alternate double bonds. Let's try to correlate its structure. Please try to see and then I'll tell you what I have done. Students, please see. Here 6 carbons are there which are represented with purple balls, and alternate double bonds are present. These are 2 double bonds, then I have left this 1 bond. Then there are 2 double bonds, left 1 bond. Then again there are 2 double bonds, left 1 bond. Still carbon valency is not complete. We will try to complete by placing 1 stick for hydrogens. So, in all the carbons 1 stick will come and will attach red balls for hydrogen. So, you can have fun in creating these structures, and the general formula is CnHn. Benzene formula becomes C6H6 as we took 6 carbon atoms. Up till now, we just have a vision of hydrocarbons containing carbon and hydrogen. But what if, my dear students, in addition to carbon and hydrogen, I have some another heteroatom like oxygen? Let us talk about functional groups. An atom or a group of atom which decides the properties of a carbon compound is called a functional group. As you can see on the screen in the given table, the functional groups containing hydrogen have been classified as 4 types. The first is alcohol. In alcohol, the presence of OH group is mandatory. Now, this is the representation of OH. This red ball represent oxygen and this purple ball represent H. There is presence of 1 bond between this OH, and you have to make sure this point that one valency of OH is free, which makes this OH a terminal group. I'll explain what is the meaning of terminal group right now. Let's suppose I have formed alkane methane. This is the structure of methane, 1 carbon and 4 hydrogens. Now I want to remove 1 hydrogen and I made 1 valency free for methane. Now this group where I remove 1 hydrogen from methane, these groups are known as alkyl groups. Where methane, I removed 1 hydrogen, the group becomes methyl. In the same way, when we talk about, let us talk about this, 1 hydrogen is removed, this group becomes ethyl. So, when we talk about methane, first we will talk about this, we will talk about methane after removing 1 hydrogen. Now my OH also have 1 free valency. So now what I will do, please see, I will simply complete this 1 valency by attaching this OH group. Wow, this is my first member of alcohol, where the formula, or you can say the molecular formula is CH3OH. This is carbon, this is 3 hydrogen, this is oxygen. Just a second, we will represent hydrogen with same colors, this way. So this is my structure for first member of alcohol, that is 1 carbon, root word is meth. Since it was a derivative of anes, methanes, so we will write meth, then we will write ane, and once I have attached OH group, the secondary suffix is ol, that is OL. So as you can see on the screen, the name of this compound becomes methanol. And if you will count number of bonds, let us count 1, 2, 3, 4, 5. So total number of covalent bonds in first member of alcohol is 5. You can create your own electron dot structures the way it was explained before. Now if I want to make second member, I already told you about homologous series in alkanes, that successive member differs with CH2 group. So if I want to suppose make the second member of alcohol family, so I will simply attach CH2 group. How? Please see. This is my carbon. Two hydrogens. Let us represent hydrogen with the same color in order to avoid confusion. Now see what I am going to do. So this was my first member of alcohol. So I will simply attach, please look carefully, I will simply attach a CH2 group and then I will attach this OH. So the first member and the second member differs only by a CH2 group. So if you count number of bonds now, it becomes 1, 2, 3, 4, 5, 6, 7, 8. So total number of covalent bonds in the second member of alcohol family is 8. If you will try to name it, there are 2 carbons, so root word becomes eth, very good. And all single bonds, so primary suffix becomes ane. And in the last, because OH group is present, so it will have all. So name becomes ethanol. So if you look at the formula of ethanol, what it will be? It is C2H5OH. Very good. Now you can make your own series for other members of alcohol. Let us talk about second type of functional group known as aldehydes. If you look at the basic structure of an aldehyde, please see, this ball represents carbon, which is purple in color. Now as you can see, oxygen has 2 valency, we already know that. As you can see, brown ball, it represents oxygen showing 2 valency, and this white ball represents hydrogen showing 1 valency. And if you see carefully, here also 1 valency is free for aldehydic group. So again, if I want to make first member of aldehyde, already 1 carbon is there. So tell me, should I place 1 carbon more or should I place something else? Yes, I have to place only one hydrogen. I will not place carbon because already carbon is there in the functional group. So this is my first member of aldehyde. With total number of bonds, let's count 1, 2, 3 and 4. And since one carbon is there, it is root word meth. All are derived from alkanes, anes, and the suffix which will put, the secondary suffix which will put, it is al, ul. So the overall name becomes methanol. In the same way, if I want to make second member, what I have to do? Again, I have to place one CH2 group for the second member. So you can place it and have fun with your own creativity. Our third type of functional group is carboxylic acid, where, as you can see the structure, this purple ball represents carbon, brown ball represents oxygen with 2 bonds. And student, this is just the OH bond which I was talking about in alcohol. So this is OH, oxygen represented with red ball and hydrogen represented with white ball. But if you will carefully see, here also one valency is free. This is also a terminal group. So if I want to make first member of carboxylic acid series, what will I do? I have to place one hydrogen only, yes, because already there is presence of one carbon. And if suppose I want to make second member, what will I do? Please follow homologous series pattern, that is attaching CH2 group. Very good. So if I want to suppose count number of bonds in the first member, it is 1, 2, 3, 4 and 5. And if I want to name it, how will I name it? One carbon means meth, all derived from alkanes, primary suffix is ane, and because carboxylic acid is attached as a functional group, then its secondary suffix will be oic acid. So if I combine all the 3 things, it will become methanoic acid. For the other members, please have a look on the screen and try to make your own structures. Now my dear students, question time. Can we make ketone with n is equal to 1 or n is equal to 2? That means, can I make ketone with 1 carbon or 2 carbon? Please think. No, minimum we need n is equal to 3. That means, if we want to form a ketone, we need minimum of 3 carbons. Please understand how. This is the representation of a ketonic group, where purple ball represent carbon and brown ball represent oxygen. Oxygen has valency 2, we already know, so 2 bonds. And here this time, 2 valencies are free for this group. That means, this is something unique. In carbonyl, that is C double bond O, which is a representation of ketone, you have 2 free valencies. So, it's a non-terminal group. Suppose if I want to make the first member, I have to place 2 carbons here. So, let us see, I am placing 1 carbon here and second carbon here. Now, for this carbon, only 1 valency is satisfied. How many valencies I have to satisfy as a whole? Total of 4. So, how many bonds will I make? 3 more. And hydrogens with red color ball, suppose. In this carbon also, how many bonds? 3. Very good. So, have a look at the structure. This is the structure for ketone. In between, you have C double bond O. In the sides, 2 carbons, making it to be a non-terminal group, and valencies are satisfied with hydrogens. So, its formula becomes CH3, CO, CH3. And how many bonds are there? Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, total number of covalent bonds present in the first member of ketonic family is how many? 10. And what will be the name? 3 carbons, so root word will be prop. All are derived from alkanes, so primary suffix will be ane, and at the end with the secondary suffix ONE is the representation for ketones. So, overall name becomes propanone. Very good. So, for the second member, please create your own fun structures and try to complete the table. Now, my dear students, let us understand some rules for naming carbon compounds. As you can see, first example in front of you. For naming carbon compounds, the first rule is selection of longest carbon chain. In the given example, we come to know that 1, 2, 3, 4, 5, 6. This can be a longest carbon chain, or 1, 2, 3, 4, 5, 6. This can also be the longest carbon chain. So, which one I should select? I should select the simple straight chain like this. Now, my second rule is to number this carbon chain, and I will number it in a way that the substituents which are present should get the lowest possible number. So, for simplicity, I am numbering it from both the sides. First, I will number from left to right, 1, 2, 3, 4, 5, 6. And then I will number it from right to left, 1, 2, 3, 4, 5, 6. Now, which numbering is correct? The correct numbering is the upper one, because here the substituents are getting the possible lowest number. Now, when we will come to name of this compound, first, as I told you in the previous slide, first part is prefix. So, here there are two prefixes, ethyl and methyl. When we will go alphabetically, first we will write ethyl. Position of ethyl is 4. So, we will write 4-ethyl. Then position of second prefix, that is methyl, and we will write 2-methyl for that. Now, in the main chain, I have 6 carbons. So, root word becomes hex. Very good. And since all single bonds are there, primary suffix will be ane, A-N-E. So, overall name of this compound become 4-ethyl, 2-methyl hexane. Let us go with the second example. Now, first rule is selection of longest carbon chain. But here we need to focus a lot. As we can see in this example, there is presence of a double bond, that is unsaturation. Whenever you see this kind of an example, you need to make the longest carbon chain which include this double bond. So, when I am selecting my double bond and the longest chain, I will circle it in this way. Very good. Now, when I do the numbering, always the numbering should start from double bond. So, my numbering will be 1, 2, 3, 4, 5 and 6. So, for naming this compound, as you can see, the substituents are present on 5th position. And if you take care of this point that there are 2 substituents present and both are methyl. So, how do we write it? 5,5 dimethyl, that is your first part which is prefix. Second part is your main chain. How many carbons are present? 6. Very good. So, we will write root word hex. And in the third part which we talk about primary suffix, it is presence of which bond? Double bond. Very good. So, we will write ene. And in front of ene, we will also specify position, and this position is 1 for double bond. So, overall name becomes 5,5 dimethyl hex 1-ene. So, my dear students, happy learning and keep practicing.